is to understand the relationship between radian and degrees and sine and cosine. All right, so let's look at the definition first. Definition of sine is b over c, or rise divided by hypotenuse, and definition of cosine, theta equals a divided by c, or run divided by hypotenuse. But we know that this is the unit circle. As you see, the radius is 1, so c is 1. So basically, the sine is b divided by 1, so whatever the height or rise is, it is 1. And if you look at the base of this triangle, which is a, this is the cosine of the unit circle. And the arc length is right here, that's the arc length of the unit circle is the radian. Okay, so radian right now, the distance from one point, starting point, is 0 right now, and if you go around the circle all the way around, the distance traveled will be 2 pi, because circumference of this circle is 2 pi times radius, and we know that the radius is 1. Therefore, circumference, which is the length all around the circle, is 2 pi, which is about 6.28. So in other words, if you think about this circle as a mile, 1 mile, then if you go around this circle, which is if you jog or if you run all around the circle with the radius 1 mile, you ended up running 6.28 miles. Now, let's understand the arc length first. So if you go around, that's 2 pi. If you go around, the degree will be 360 degrees. Right? And then the radian will be 2 pi. Okay? Now, if you go around the half of that circle, degree-wise, it's 180 degree. And the radian-wise, it's half of 2 pi, which is just simply pi. Right? So if you go around the circle, so right here, radian is pi. If you go to 90 degrees, then it is degree-wise, it is the same as half of 180 degrees, which is half of pi. If you go to 45 degrees, then that's going to be half of, just make it a little bigger. Oh, maybe I cannot. Half of this guy, which will give us pi fourth. And then what if it goes 60 degrees? I mean 30 degrees. Oops. 30 degrees is 1/6 of 180 degrees. So it should be 1/6 of pi. So 1/6 of pi, or just simply pi 6. That tells us that 60 degrees will be double of 30 degrees. Therefore, it should be double of this guy, which is pi 6. Or just simply pi third. Good. So now if you look at this, so what would be the coordinates of this, right? So let's look at this guy, and let's set it to 30 degrees. Ooh, somewhere over there. Okay, there you go. So 30 degrees. So this triangle is now a special triangle, which is half of equilateral triangles because it's 30 degrees, 60 degrees, and 90 degrees. And if you have a copy of this, and if you reflect that over x-axis, now you see that this is equilateral triangle, but we only have a half of it, right? So this is 30 degrees. By Pythagorean theorem, we can find out all the lengths. Well, first of all, hypotenuse is 1 because this is a unit circle, okay? And obviously, this is the equilateral triangle. So if you look at this guy, this length is exactly, all the lengths is exactly the same. So this O to this guy right there is 1, and from here to B is 1. And you see that the BD is half of it, half of the one side, and we know one side is 1, so B should be a half, and that's what we get right there, B over C. And also, cosine will be right there, right? So cosine is A divided by C, which is this also we can find out by Pythagorean theorem, which is A squared plus B squared equals C squared. And if you plug them in, now we know that A is, we don't know what the A is, but we know B is half, and we know C is 1. So if you plug them in, you'll have 1 over 2 square, A squared plus 1 over 2 square equals 1 square. And if you solve for A, you'll find out that A is square root of 3 divided by 2, which is about 0.87. And as you see, the coordinates of B is, which is this guy, is exactly the same as sine and cosine. Let's set this B up onto 45 degrees. Oop, oop. Is this the close I can get? Okay, that's good enough, I guess. So this is special triangle because this is the half of square. So you see the square. Now square with the diagonal 1. And by looking at this Pythagorean theorem, we know that A squared plus B squared equals 1. And so since these A and B are exactly the same, because as we see, this is the half of square, therefore BD and DO and O to this guy to B are exactly the same because this is a square. So length A and length B should be exactly the same. So this right here should be A squared, which will give us A squared plus A squared equals 2A squared. And if you solve for A, you'll see that A and B will be square root of 2 divided by 2, which is about 0.71 and 0.71. So that's the relationship between the coordinates and the sine. And of course, you can go past the 90 degrees, but when we set 135 degrees, which is about this one, that's good enough, right? That's exactly the same triangle that we had before, but the arc length from here now is 135 degrees. So this guy 45 plus 90 degrees. So it's 3 over 8 pi. Is that right? No, 3 pi over 4. 3 pi over 4. But you see that this triangle is just reflected over y-axis. So the A is negative of this, right here. You see that? Negative 0.71. And the rise is still the same because it's positive. And if you go around that circle, if it hits 1, then AC will be A over C, which is the cosine, is 1. B over C, which is sine, is almost 0. If you pass that, the sign changes, but it's pretty much the same. So here's a 60 degrees, 30 degrees triangle right here. But this is basically the same as the other special triangle, which is half of equilateral triangle. If you reflect that, you can see it. Now, this guy is 1 because it's the radius. Therefore, A is a half, and the height is negative of square root of 3 over 2, which is about negative 0.86.